Yo, 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 this is Mr. O. About inverse function. Inverse function. Okay, we say inverse is the switching of x and y. Okay, make sure you guys have your notes or your packet so we can complete this. So let's go ahead now. The inverse of a relation R is written as like an R with a -1 as an exponent, or inverse of R. To find the inverse of a relation, you just have to switch the x and the y. So the y becomes x and the x becomes y. Okay. The one-to-one relationship. If a relation and its inverse are a function, then it is a one-to-one relation. Okay, so a given relation has to be function at the same time its inverse has to be function for you to consider that they have a one-to-one relation. So what's the meaning of that one? For example, let me give you an example here. A relation R, 1 -2, 2 4, 3 -1, 4 -2. Is this a function? The answer is yes, because if you remember, none of the x here repeats. The x's to the domain are 1, 2, 3, 4. None of them repeated, so it's a function. But when we find the inverse, again, how do you find the inverse? We switch the x and the y. So this will be now -2, 1, 4, comma 2, -1, comma 3, and -2, comma 4. Is this a function? The answer is no, because I have -2 here and a -2 here for the first coordinate, and that means this one here is not a function. So therefore the relation and the given inverse, the inverse that we found, are not one-to-one relation. So is R a function? Yes. Is inverse of R a function? No. So is R one-to-one? No. If this was a yes, then the answer will be yes for the one-to-one relation. Next, I have here a mapping of a relation wherein we know that 0 maps to 6, so 0 maps to 6, 1 maps to 2, and 11 maps to 6 there. Now, we will find the inverse of this relation by switching the x and the y. 6, 0, 2, 1, and 6, 11. Is R a function? The answer is yes, because none of this x value repeated. 0, 1, 11. Is the inverse of R a function? 6, 0, 2, 1, 6, 11. There have a 6 here and a 6 here, so the answer is no. So therefore, is R one-to-one? The answer is no. Horizontal line test. Recall the vertical line test. Vertical line test is when we would like to determine if a given graph of a relation is a function by drawing a vertical line. If it crosses only once, it's a function. Here, both of them are a function because when we draw a vertical line, it crosses only at one point. The horizontal line test is used to determine whether the inverse of a relation is a function. So if we draw a horizontal line, how many times it crosses the graph? Only once. So therefore, the inverse is a function, and this is a one-to-one. So the answer is yes. What about here? Here, when we draw a horizontal line, it crosses more than once. So therefore, the answer here is no. So horizontal line test is for us to check if the inverse will be a function. Okay, the main thing about this one is finding the inverse of a given function. The inverse of a function f of x is written as like an f of x also, but there should be a negative one on top of the f, okay, or as an exponent of f, and we read that one as inverse of x. Sorry, inverse of f of x. Here are the steps in finding the inverse of a function. Step one, replace the f of x by y. So here I have an example. I'm going to change this f of x by y. So y is equal to 5x. Step two, interchange x and y. Means say swap or switch the x and y. The y becomes x and the x becomes y. Step 3, solve for y. How am I going to isolate the y here? I'm going to divide this by 5, divide this by 5, cancel it out. So therefore, I'm going to have now x over 5 equals y, or I can make it y is equal to x over 5. In step 4, rewrite y as inverse of f of x. So therefore, this will be inverse of f of x equal to x over 5. And this is the inverse of f of x equals 5x. One more time. F of x is equal to x minus 8 over 3. Again, step 1 there, change the f of x to y, and this becomes now x minus 8 over 3. Step 2, swap the y to x and x to y. So this becomes x now. This becomes y minus 8 over 3. Then try to isolate the y here. I'm going to multiply here by 3 and by 3 here. This cancel out. That give me a 3x equals y minus 8. And I'm going to add 8 here to isolate the y. This cancels out. So now I have y is equal to 3x plus 8. And the last step is replace your y by inverse of f of x, 3x plus 8. And that's the answer. Next, f of x is equal to x squared minus 9. So again, we will replace the f of x by y, and this is x squared minus 9. Swap or interchange the x and the y. So this becomes x, this becomes y minus 9. And how do I solve it? Add 9 here, add 9 there. So x plus 9 is equal to y squared. And then I'm going to take the square of that one in order for me to isolate the y. Take the square of this. Therefore, I will have now cancel this out. This will be y is equal to the square root of x plus 9. I can swap them, make it y is equal to the square root of x plus 9. And I can replace this y here by inverse of f of x is equal to square root of x plus 9. And there you have it. And that's how you find the inverse of a function, knowing if it's one to one. And as always, kaboom.